Hello everyone. I thought it would be a good idea for me to create a video working the Unit 2 review problems for you. So we're going to go ahead and get started with that. Numbers 1 through 10 tells you to solve absolute value equations and inequalities, and if your inequality is an answer, to write it in interval notation. So number 1, we have absolute value of x minus 2 plus 10 equals 20. In the case where your only variable in the problem is inside an absolute value, I would try to isolate it first. However, you're going to see once we get down to numbers 9 and 10, you really can't isolate that absolute value any further. And I'll show you why once we get there. Okay, so the first thing, I'm going to subtract 10 from both sides, and that will give me 10. Now what you do from this point, you take your absolute value part and you create x minus 2 equals positive 10, and you create x minus 2 equals negative 10. And the reason that you do that, you know that the inside has to be 10 in order to get absolute value of 10 equals 10, or the absolute value of negative 10 equals 10. So I just set my insides equal to 10 and equal to negative 10. You solve both of these, so if I add 2 to this side, I get 12, and if I add 2 to this side, I get negative 8. Then you can use mental math, but you have to check both of these answers in your original equation. So check both in original equation, and you can, once again, you can use mental math. You don't have to show me that part. So you can use mental math if you prefer or if you want to. So if I take and plug in 12 into my original, let's see if I get 20. You have the absolute value of 10, which is 10 plus 10, and that equals 20. So that one checks off. And that was checking 12. If I check x equals negative 8, you get negative 8 minus 2 inside absolute value, plus 10 equals 20. This gives you absolute value of negative 10, which is 10 plus 10 is 20. So that one checks out. So both work. And number 2. Number 2, I have negative 4. Absolute value of x minus 3 minus 8 equals 4. I am going to get the absolute value part by itself. So we're going to add 8. And that leaves me with negative 4 times absolute value of x minus 3 equals 12. And then divide both sides by negative 4. And you get x minus 3 equals negative 3. Now let's think about this common sense. This is saying that the absolute value of some number is going to come out to be negative. And you know that can never be the case. The absolute value is the distance a value is from 0 on the number line. So absolute value is never negative. So automatically I can say no solution. Or you can say the empty set. I don't think Math Excel has the empty set. Well, it does in some cases and it doesn't in others. But, so number 2 is no solution. You can't take absolute value and get a negative number. Okay, moving on, number 3. You have the absolute value of 6x minus 100. Getting a little carried away with the ones. Plus 7 equals 1. So once again, isolate your absolute value. So I'm going to subtract 7 from both sides, and I get absolute value of 6x minus 100 equals negative 6. And once again here, let's use common sense. They're saying the absolute value of all of this comes out to be a negative. So no solution. Or the empty set. And same reasoning applies. Can't take the absolute value and get a negative number. Number 4. You like those, don't you? You wish I would put all of those on the test. Number 4, we have absolute value of x plus 5 minus 2 is greater than or equal to 11. I'm going to come out to the side, and we're going to have a quick lesson on what your answers will look like if it's greater than or equal to. So if it's greater than or equal to or greater than, that's greater. Think about or, greater or, so we're going to join both solutions. If it's less than or equal to or less than, that's less than and, less than and, less than and, that's and you're going to find out where the answers intersect. Now, otherwise, if it's no solution, or your answers might be no solution, just use mental math to check for no solution. And you'll see what I'm talking about in a second. So use mental math, greater or less than and, greater or less than and, greater or less than and. So we're going to make a side note of that. And you're going to see what I'm talking about. If it's no solution and it's greater than, you're going to see how you'll join both solutions. So your solution to that, if it's greater, will look like negative infinity to some number, either parentheses or brackets, union, bracket, parentheses, some number to infinity. That's an example of what your answer will look like. Example of answer for that one. If it is less than and intersect, this is what your answer will look like. So example of answer, your answer will look like either parentheses or brackets, number to another number, parenthesis, bracket. That's what they will look like. Otherwise, it'll be no solution. So number 4, let's isolate the absolute value part as much as we can. I'm going to add 2 to both sides. And that leaves us with the absolute value of x plus 5 greater than or equal to 13. Now, in a similar way that we solved equations, you're going to take the x plus 5 and you're going to say greater than or equal to positive 13. This is for the positive part. And then for the negative, you're always going to flip your sign. So I'm going to say x plus 5 less than or equal to negative 13. So negative, you keep the absolute value the same, but you have to flip your symbol and number becomes negative. So flip your symbol and your number becomes negative. Now you solve both of those just like you would in inequality. So I'm going to subtract 5 and that'll give me 8. And I'm going to subtract 5 and that'll give me negative 18. And how you know what your solution looks like, you just plot both of those on a number line. And we know, of course, negative 18 comes to the, or occurs to the left of 8 on the number line. And for greater than or equal to 8, you've got and the closed-in hole at 8, and it's going to the right forever. For less than or equal to 18, you've got a closed-in hole at 18, and it's going to the left forever. And how you write that as one final solution is you would say it goes to negative infinity because I'm joining, right? This was greater, so it's or negative infinity to negative 18, bracket because it's closed in at 18, union, bracket 8 to infinity. And what this actually means is that any number in this range will work in that inequality. If I plug in any numbers from negative 18 or smaller, it's going to work. If I plug in numbers 8 or larger, it's going to work. But if I plug in 0, it will not work. Numbers in between 18 and, or negative 18 and 8 will not work. Okay. Number 5, absolute value of x plus 2 less than negative 4. Isolate your absolute value part as much as possible, subtract 2, and you get the absolute value of x is less than negative 6. Now, let me go back before we answer number 5. Look at number 4. I told you this is how you're going to, well, I told you would use mental math to check for no solution. As you isolate the absolute value part as much as you can here, think about, can I take the absolute value of a number and it be greater than or equal to 13? Well, yes, I can take the absolute value of a number and have the possibility that it's greater than or equal to positive 13. So that's why you keep solving that one. Now, number 5, if I'm checking this using mental math, they're telling me the absolute value of some number is less than negative 6. Well, that cannot be the case. I can't take the absolute value of a number and actually be more negative, if that makes sense. So this is not possible. No solution. And you don't even have to do any more work. No solution or either one of those. Number 6. 3, absolute value of 2x minus 1 minus 10 less than or equal to negative 1. Okay, let's isolate. You always undo addition or subtraction first, by the way. I would not divide by 3 first because you're going to have to divide 10 by 3 if you do that, and that would be gross. So let's add 10 to both sides. And when I do that, I'm left with 3 times absolute value of 2x minus 1 less than or equal to 9. Also, another common mistake I see is people wanting to distribute 3 to 2x and 1. Please do not ever do that. You're never ever distributing a number outside to absolute value inside. Okay, from here I'm going to divide both sides by 3 to further isolate, and I get absolute value of 2x minus 1 is less than or equal to 3. Now, once again, you're going to have you've got a positive part, and you're going to have a negative. The absolute value always stays the same. So you're going to keep the 2x minus 1 the same in both cases. So notice that. But I drop absolute value. This part, if it's positive, I keep that symbol, say less than or equal to 3. But when it becomes negative, notice here that I flip that symbol, say greater than or equal to negative 3. Okay, let's solve each part. So we're going to add 1 to both sides, and I get 4. And then divide by 2, you get x is less than or equal to 2. Negative, I get 2x greater than or equal to negative 2. When I add 1 to both sides, divide by 2, and I get x greater than or equal to -1. When you plot these on a number line to see what your solution looks like, you're going to be able to tell whether you're joining them or whether you're finding out where they intersect. If you see an intersecting part, that's what you write. If you see that there are two different solutions with a gap, you're doing the or the union. So I'm going to put -1 here, 2 here. The solution for 2, I fill it in at 2 because you got equal to, and it's less than, so it's shaded all the way to the left. The solution for -1 is filled in at -1, is shaded all the way to the right forever. Notice the only part where they intersect, and once again, the reason that this is intersect is because it's less than, which means and you're just finding out where the two solutions overlap. So notice that where they overlap is from here to here, and -1 is filled in on both sets, so I use a bracket. So I just say from -1 to 2. Number 7. Number 7, x plus 1 is equal to 3. You're gonna have a positive part and a negative. Notice that the absolute value is already by itself. They actually throw you an easy one down in the mix here. So I take x plus 1, I set it equal to 3. I take x plus 1 and I set it equal to -3. Solve both of those. Subtract 1, you get 2. Subtract 1 here, you get -4. You have to take those and plug them in to check when it's an equation. So check using mental math if you want to. So x equals x equals 2, 2 plus 1, absolute value. So that one works. -4 plus 1 is -3, but the absolute value of it is 3. So they both work. Number 8, we've got the absolute value of x plus 1 is greater than 0. And if you think about that one, it is really close to being all real numbers, because we know that when we take the absolute value of any number, it's got to be positive, so it's going to be greater than 0. But what keeps it from being all real numbers is it doesn't say it's greater than or equal to 0. But it's really close, and you're going to see that. So this is the inequality. Notice that it's greater, and we say greater or. So this is going to be a case where we join our answers. So join, union. So join, union. All right, and how we determine that is you just take it. You've got a positive part. X plus 1 greater than 0. For the negative part, remember we're supposed to flip our sign, flip our symbol around, and we're supposed to change that number to negative, but 0 is neither negative nor positive, so it just stays. Solve each inequality, subtract 1, so you have x is greater than -1. Subtract 1 here, you have x is less than -1. When you plot those solutions on the number line, notice the only number you have in both cases is -1. So for this particular piece here, I've got an open hole at -1. It's shaded to the right forever. Notice for this piece, I've got an open hole at -1, and it's shaded to the left forever. The only value that is excluded in this solution is -1. So if I'm writing that in interval notation, I say from -infinity to -1, parenthesis because it's not included, union -1 onto positive infinity. Number 9. We've got absolute value of 2x plus 2 plus x greater than 2. And this is one of the cases where I told you you can't actually isolate absolute value because you've got an x outside of absolute value. But you solve this one in the same way that we've been solving the previous. So we don't have any isolating to do first, so we can jump right to creating our positive and our negative versions. So positive, we've got, you drop your absolute value, so 2x plus 2 plus x greater than 2. So for the positive part, your entire problem stays the same except for no absolute value, and then you would distribute if you had that. For the negative, everything stays the same except for you flip your symbol and that number becomes negative. Now let's solve each part. When I combine like terms here, I get 3x plus 2 greater than 2. Let's subtract 2 from both sides, and I get 3x greater than 0. Divide by 3, I get x is greater than 0. Combine like terms, 3x plus 2 less than negative 2. Subtract 2 from both sides, I get 3x less than negative 4. Divide by 3, you get x is less than negative 4/3. When you plot both of these on the number line, negative 4/3 comes before 0. Now I've got x greater than 0 has an open hole at 0, going to the right forever. And x is less than 4/3, open hole at negative 4/3, going to the left forever. Now, I'm going to ask you, do you think that you're finding out where they intersect, or do you think that you're joining them just based on what you see? For this case, we're definitely joining both solutions. And another dead giveaway you're doing that is you have greater, and that's always going to be an or solution. So I'm going to say this goes from negative infinity to negative 4/3, parenthesis because it's open, union parenthesis 0 to infinity. Number 10. You have 3 times absolute value of x minus 3 plus absolute value of x is less than 15. So this one definitely looks gross. We have 2 absolute value parts, and so I'm sure that you're looking at that thinking I'm going to skip that problem, but you're not. We're going to persevere and power through it. We solve this in the same way that we just have. You can't isolate absolute value here. And I would not divide by 3, even though the 3 would go away here, it would create 5. But here it would create a 1/3, so it would create a fraction. And we don't particularly like working with fractions. So this is what you're going to do. You've got a positive part, and you also have a negative part. And just like in the previous problem when I told you, you rewrite your problem for the positive the same. Notice that I change these absolute value become parentheses. I drop absolute value here with x, and I say less than 15. Keep the symbol, keep the number positive. But for the negative, almost everything's the same, except for flip symbol, number is negative. Okay, so we're going to distribute 3. You get 3x minus 9 plus x less than 15. Combine like terms, 4x minus 9 less than 15. Add 9, you get 24. And divide by 4, and that leaves you with x is less than 6. This side, we're going to distribute 3. Then combine like terms, you get 4x minus 9 greater than negative 15. add 9 to negative 15, and that gives you negative 6. Divide by 4, you get negative 6/4, which reduces to negative 3 over 2. So that's our answer for that side. Now, based on what you see, negative 3/2, based on what you see when you plot it, you'll know what to do with your answer, hopefully. Once again, let's go back. I haven't been doing this. I'm so sorry. In this problem, I mean, think about it like this. They're telling you that you can have 3 times the absolute value of some number plus the absolute value. So 3 times the positive plus the positive is less than 15. That definitely is a possible case because you've got numbers ranging from 0 to up to 15 that are positive. So we can have a possible case. So that's why this one does have a solution. It's going to be a small solution range, you're going to see, but it does have one. So we've got negative 3/2 and then 6. So let's plot our two cases. So less than 6 has an open hole at 6 going to the left. X greater than has an open hole at negative 3/2 going to the right forever. So based on what you see, do you think that we're joining or do you think we're finding out where they overlap? Definitely finding out where they overlap, and the reason is this was a less than, which is and. Less than and intersect or overlap. So notice the only place where you see a red solution on top of a pink solution, the only area is from here to here. And I say negative 3/2 to 6 is the only place. It starts at negative 3/2. I put parentheses because it's open on that pink solution, but it stops at 6, and I put a parenthesis around it because it's open on the red solution. All right, number 11. We are rewriting this with our absolute value. So number 11, rewrite 3 absolute value of x minus 6 minus 4 as a piecewise. So if you'll recall, the way that we did that, we found what made your turning point, which is just what makes x minus 6 equal 0. You're only looking at the absolute value part, what would make the guts or the inside equal 0. So we add 6, so x equals 6 would be that. Then you can sketch a number line if you want to. Put your turning point in the middle. Anything to the left of anything to the left of 6, such as 0, -1, if you plug in negative numbers or anything less than 6, what would happen to the inside? It would become negative, right? So when x is less than 6, the insides are negative, so you remember that we did the opposite. So everything is going to stay the same in that, except for this absolute value part is going to become negative x plus 6. And that's the only thing I changed in that. When you're above 6, if I plug in numbers greater than 6, notice if I plug in 6, I get 0. If I plug in 7, 8, 9, 10, I'm going to get positive insides. So insides are positive, and that's where it stays the same. So I got 3 it stays the exact same, x minus 6 minus 4. And remember, when it stays the same, that's the part that gets the equality. And all I do to rewrite this in piecewise is I say y equals swirly brace. Let's go ahead and clean this equation up a little bit. I've got negative 3x plus 18 minus 4. Yes, you need to simplify them. So this is going to be negative 3x plus 14, and that was when x was less than 6. When I distribute 3 to here, I have 3x minus 18 minus 4, and that becomes 3x minus 22. And it, once again, it doesn't matter. I could write the purple one on top, and it doesn't matter. But that was when x was greater than or equal to 6. Okay, number 12. Rewrite this without absolute value. So let's determine our turning point. Turning point is going to be negative 1. And let's see what happens when we plug in numbers that are less than 1. Let's see what happens when we plug in numbers greater than negative 1. When you plug in numbers less than negative 1, such as negative 5, negative 6, notice it's making that negative. And be very careful here. The only thing that is changing is the absolute value part. Notice on both sides, I keep that negative. Distributing the negatives is one of the last things you do. Plus x plus 10. You have to determine based on testing values. You have to determine based on testing values, are the insides going to stay the same or going to change? If I plug in numbers less than negative 1, that is going to change to negative x minus 1 because you get negative insides. If I plug in numbers greater than negative 1, it's going to make my insides positive. So that would say x plus 1. And let's go through and simplify that. So let's distribute the negative. This becomes positive x plus 1 plus x plus 10, which comes to 2x plus 11. When I distribute the negative here, I get negative x minus 1 plus x plus 10. The x's go away, notice that, and I'm left with 9. So the way that you write that in piecewise, y equals swirly brace, you've got your 2x plus 11 part, and that was for when x was less than negative 1. I've got the green part, which just simplified to 9, and that's all you have to write. And x is greater than or equal to negative 1. It got the equal to part because that's where it stays x plus 1. Okay, so I'm going to end the first part here with 1 through 12, and then I'll finish working 13 through 20 on a second video for you. Have a great day.